So our Aldol condensation product, which I think I labeled DCL-10-62A, but it really should be 62B because the stuff before recrystallization should have been A. So I've labeled a vial 62B. I'm going to transfer that material to that vial. But first we need to get a mass on our beaker so we know what our purified yield is. So it looks like we got 8.806 grams on our beaker. And I'm going to mass the vial as well. Looks like moving around a lot. Looks like 6.103 grams. 6.103 grams on the vial. And 8.806 grams on the beaker. We'll just write those down. So we're going to take an IR spectrum of this. I've grabbed an IR kit. Hopefully it's clean. Looks clean. So we're going to set our color on there. And we're going to transfer a little bit of this solid to the mortar and pestle for measuring the IR. That's plenty. And then try to get the rest of it into this vial for later use. I got a little funnel here that I've prepared, which I'll have to hold with my hand, obviously. So I'm just going to break this up a little bit so it'll go through the funnel more easily. You can see that it's very light mat of crystals. Just reach in there and pull the residue off the walls. There's a little bit left. And we'll try to push down as much as we can. Got plenty of material. So we've run GC-mass spec on this already. We're going to run an IR. And then we're also going to be getting proton and carbon NMR and melting point data on this compound. Very fine crystals. Let's tap that down a little bit. See if we can get the rest out of the beaker. Probably as good as we're going to get. And we'll just sit that back out of the way. sit that in there. Wipe up a little bit of the mess. So those solids will just sit until we're ready for them to get the rest of the data. Now what we want to do is grind that, just smear it all over the walls of the mortar and pestle. That looks pretty good. It's all stuck. Grab a scoop of KBR. And then we're going to mix that thoroughly and grind the KBR a little finer. Hopefully get a good pellet out of it. So we want to get all that solid off the sides of the pestle. And off the walls of the mortar. To be a nice powdery mixture that flows pretty freely. So when we tap it, it gathers in the bottom. Oh, looks pretty good. I'll grab a different micro spatula, nice clean one. Should be at least one more micro spatula in there. There we go. And we're just going to transfer enough of that compound in, that mixture rather, to cover the bottom of the die. Tap that down to make it a uniform coating without any gaps. Always a challenge to tap it without lifting the collar. Looks pretty good. Transfer that in there and squeeze that tight. I need to loosen it a little bit. There we go. Got that tight. Go collect a background while we're waiting for that to fuse. Making sure our chamber is empty. Collect background. Please prepare to collect background spectrum as code for take your sample out. And we have a nice looking background with the water and CO2. It says single beam. Perfect. We don't need to save that. It should be fused enough now so we can go and open it up. There's a nice sharp wrap. Pull that apart. And hopefully we have a relatively transparent pellet. Or at least translucent. Yeah, looks decent. So we are now going to collect our sample. can put our sample in. And this is 62B dash, and I can't remember how many GC mass specs I took, but I think I took at least 2 different GC mass specs. I'm going to call this 62B-4 because I think I took 3 GC mass specs. So we're okay that. We are prepared. The sample's in there. Background age is a minute, so quite recent. And that's nice looking. We got at least 5% transmittance. None of these are flatlining at the bottom. Got 55 at the top. Looks like we've got a nice looking spectrum. The baseline is sloped, so we will need to correct it. But let's save that file first. Migrate to the data folder. Set file name to title. So now we can correct our baseline. This is all baseline here. It's likely that these aren't actually baseline, that it never goes all the way back to baseline, so I'm not going to correct those away. So we can replace that. That looks good. We're going to want to change our display limit. Subtract 6 or 7, so I'm going to call this 41. That way there'll be room for the peak labels. And I'm going to move this out of the way. And double click on that and add a comment. And I believe this is the Aldol condensation product from K2 and B4. Have that in the corner out of the way. And now I want to find peaks. I want these, but I don't want that many in here. So I'm going to label those separately. I'll just put this here so that I get that 1425 peak, and then everything else that's smaller than that, well, maybe I want that one. 479, no, I don't care. So I'll label these separately so I don't get too much of the crap in there. So we're going to replace, and we're going to save that. And then I'm going to use my T here, both to label these peaks, because they matter, even though they're small. And to move these peaks to where they can be more easily seen so we know what they're pointing at. And it just makes it look prettier when you print it, so it's easier to find the data you're looking for. We don't have a lot of overlapping lines, and so that everything's on scale. That peak at 1156 is obviously a shoulder, so that one I can just delete. I don't need to see it. This peak might matter. I'm going to label it. It's large enough that it could be being reported in literature. So that looks good. We'll save that, and we will print it. now do a search against the library. It's no good matches. 41.71 to para-anisaldehyde, 4-oxaloacetophenone. Whether that useful information is useful remains to be seen, but we'll print it anyway. Nothing's a good match, right? 41% matches. Terrible. But for completeness, we always include these. These compounds would not be expected to be in the search library. But we'll save it, print it, and we'll do a spectral interpretation. And it thinks it's a para-substituted aromatic hydrocarbon. There is a peak there in the para-substituted aromatic hydrocarbon region. There's sp2CH stretch. And it thinks it's an aliphatic ketone, and it actually is an aliphatic ketone. You'll notice that the carbonyl group isn't exactly where it was expected to be, but that's because that carbonyl group is adjacent to a carbon-carbon double bond, and that causes it to move. So let's print that result as well. And we'll call that functional. And then those can be uploaded. I won't save that. As a matter of fact, I'll close Omnic. And this computer has been giving us hassles, so I'm going to restart it and hope that some of those problems go away. So we'll just take our sample back. And we will pop that out. And set this side to be cleaned up and put away. So we have our IR spectrum now.